I don't have any evidence to show we haven't been there or that it's been staged or whatever.
No, well that's the same as me. I don't have any evidence, and there's nothing that I can experience myself that would give me that certainty. So I have to say that it's a leap of faith then if I believe an authority or somebody else telling me something. And I think that's okay as long as that discernment is made and understood to be different from what natural science is.
I mean, it's clear that everyone is subjective to what they experience and believe. So obviously everyone should have their own opinion on how things go on and how everything surrounding them affects them. I mean, there's people who believe really hard in I don't know, a higher existence or whatever. It's not like I don't believe or like I believe, or everyone has their own beliefs, and what they do defines what, I mean, they do what they think is right by them.
Yeah, but would you not? I mean, I'm a direct realist, which means that it's very
realist as well.
For me, it's all very much about natural science, and that has to be the basis of our knowledge, and that anything that contradicts that is either going into the realms of belief, which could be religion, believing in a higher God or something.
Religion is like a totally different subject. I mean, it's
totally
do you think
science and religion? Do you think science and religion sometimes have many things in common? Because you have to believe and have faith.
It's not really a subject I'm really, let's say, well versed in.
Yeah.
I mean, I prefer more science than religion. So
absolutely,
I wouldn't really have the necessary tools to explain what religion is or how it affects or what it does.
But you would agree, though, that religion does require a leap of faith and a belief without being able to experience a God
without
or
any
whatever,
proof for it.
And if science is also going down the path of giving us things that all we can do is believe or have a leap of faith or trust in authority, that has to be different from real natural science that we can observe and repeat and measure and test ourselves.
Should be.
I think that's a
by definition it sounds different.
So again, for me it comes back to the fact that if we have facts that, I can argue against a hypothesis, but I can't do it the other way around. That's a logical fallacy to take a hypothesis and argue against facts. That's not scientific.
Indeed.
And again, I can only come back to the fact that if I'm supposed to be on a spinning space ball with water defying nature, then that contradicts for me what is a natural fact of life. So that's why I find it now very hard to believe what I'm being told, and I think one of the things that we're trying to do is just to help people, or to get people to think critically. We're all natural scientists, really, and we don't need specialist equipment to see the facts of life.
But I think, for example, going on about the water argument, for example, clouds and rain. Why does the rain fall on the Earth's surface and not in the atmosphere, for example?
Well, if I give you a helium balloon, I give you a helium balloon and I let go, then it flies up into the air. So that's defying gravity, or why is it flying upwards?
It's flying in the air, but
it's because of
to a certain point.
It's because it's going upwards. It's not falling down because
it's lighter.
Because it's to do with pressure and density and volume.
Its mass is lighter, so it's not as affected by the gravity as other objects.
But it defies gravity. Everything else gets pulled down. Large bodies of water have to get held down by gravity, right?
It's denser than helium.
So there is an explanation about why things fall that has to do with pressure and density and volume, right?
For example, oil in water.
So do we need gravity to explain why things fall? And do we need gravity to explain why things go up? Because
it depends really, but mostly I think everything could be defined or affected. I mean, everything is affected by gravity. So,
have you heard of the equivalence principle?
Not exactly. No.
The equivalence principle is a mathematical or a physics principle that basically equates gravity, the F equals G m divided by r, with the principle of acceleration in a free fall, so F equals ma. So it's equivocating those two statements, which
like terminal velocity.
Yes, It's exactly, if you like, what Newton's theories were, and nowadays it's called basically the equivalence principle, where gravitation is equated to the natural phenomena of substance falling through mediums at a certain rate depending on their relative density and the relative pressure. So there is
reach an equilibrium.
Yeah, so
which they cannot go faster, or
so there is an alternative explanation which has been equivocated, equivalence principle, to the gravity. Nowadays, I think most of us are taught gravity, and that's the standard answer that we usually hear. But there is another answer for why things fall down and up and go up,
which is
exactly that: how different substances fall through different mediums depending on their relative density to each other. So you're going to hit the Earth and you can't go any further. But
for example,
helium balloon
a
will
rock
rise.
isn't. I mean, this applies to fluids.
No, to all substances.
An object through a fluid.
Yes, if you go into water, then it's buoyancy. It's the Archimedes principle.
Yeah,
explains everything. You don't need to invoke gravity. So what I'm just trying to say is that in physics there are things that have been equivocated to appear to be the same thing, although they're two separate concepts, and one can exist quite fine without the other. Sure. So gravity is a mathematical theory that hasn't ever been necessarily proven to be correct. I mean, they're still looking for gravitational waves and gravitational particles, right?
There's a lot of theories that have been discovered, proven, tested, and there's still a lot that hasn't been discovered and still has to be discovered.
Can I give you another example? So when we here on Earth, we live in a pressure system, right? With different layers of fluid and gas all the way up until, well, wherever it stops, we don't quite know. But what we're told is that those layers and those pressure systems get less and less and less until you hit the vacuum.
Yeah.
Whereas, anything that we see on Earth, if you have two different pressures or two different substances, whether it's fluid or glass, they need a solid separate barrier, otherwise they will equilibrate. So, one gas will mix with the other, and if you have a vacuum and no solid separation barrier, then the vacuum of space should theoretically suck everything off the Earth, right? Unless, and the word is probably going to be gravity, is invoked again as the explanation for why that doesn't happen.
For example,
why do you
there's
think
gravity on the moon or on Mars or whatever, so
again you're making an assumption that these things are physical objects that you can land on.
Yes, why not?
Whereas I deny that because I again have no measurable testable evidence, and only because 500 people told me I can't take that.
It's not like I've been told that it exists and that's why I believe it exists. It's just I see it in the sky, and
what do you see?
Right now, not right now, obviously.
What do
in
you
the
see?
night. But you see them being there, stars and planets, and why
sure,
shouldn't
luminaries
they
are there.
exist?
I'm absolutely with you that luminaries are there. The question is just what are they? How far away are they? And are they space balls?
What else could they be?
That's what I don't know. I'm quite willing to, and I think every science person should say, I don't know.
Obviously from here we see them as round shape, but for example, it could be an asteroid or something that's totally not round, but still it would be there.
Sure, we see, I'm not denying that we see luminaries that are disc-shaped, yeah? But the question really is, we're told that we've gone there, we've landed on them, we've sent probes and all those things, and I refuse to accept evidence that just because 500 people have shown me a picture, yeah, or told me a story, because that for me is a leap of faith, yeah, but it's a belief.
It's the same as it's for me, believing it is. So.
But I mean, Earth is said to be a space ball. We're apparently hurtling through space, yeah. Yet we see the same constellations, for thousands of years without them ever changing. If we're going round the sun, then when you're going round the sun on the other side, you should expect to be looking out that way, seeing different constellations. And when you're on this side, we don't. So there's a lot of contradictions with the pressure, with the water, with how the stars are seen, to what we're being told. Do you not think so?
Constellations, for example, are different. I mean, there's different constellations that can be seen from the northern or southern
depending on where you are, sure.
So it also has to do with the tilt of the axis of how the Earth spins, and
sure.
You're obviously not going to see stars that are normally seen in the southern hemisphere if you're not going there to see them, because they cannot be on the northern hemisphere sky, or
Sure.
Yeah, that they are the same.
They're the same where you are.
There's also changes. I mean,
well, Polaris doesn't.
Time, for example, is a basic. Time is made by man, so it's not necessarily a universal. We made time, and we define everything by time.
Well, I think time is a natural quantity because I can measure heartbeats, I can measure pulses, I can measure water drips,
for example, a human life is too short to measure changes in the universe. It's the same, for example, with history. There's different time scales. For example, historical time, geological time, which is totally a totally different scale. You cannot see, I don't know, a rock forming from sand in 100 years.
No,
which is a human lifetime, let's say, which is too.
That'll be a good one. A good lifetime.
Yeah. But it takes thousands of years for it to form. So that's why we cannot see or prove that the universe is changing.
So again, you're taking something on faith, then, right? I mean,
sure.
As long as that's, I think my side is not to convince you of something else. As I say, I don't want to debate.
You have your opinion. I have my opinion. Our beliefs.
I think it's just important that people discern the difference between what is a belief, and what is real science,
Sure.
And I think very often that border is swum back and forth without people actually realizing it.
I mean, there's different people everywhere. I mean, there's people who don't even know the difference between right and left, to be blunt. So obviously, if they cannot discern which way is right and which way is left, why should they be able to discern scientific fact?
Observing it for yourself, maybe?
Perhaps. But that's what I want to say, that everyone has their own opinion.
Yeah, but you can't deny a fact, though, can you?
You cannot.
If there's a fact, like I usually use the analogy, there's three entities here at the moment talking.
Yes.
Now, I think that's a fact, isn't it? Would you agree that's a fact?
Sure.
So we can agree.
Fire is hot, you know. Yeah. I mean, if you put your hand in a fire, it'll burn. We can all agree on that, yeah.
Sure.
And ice is cold, and you know.
Yes.
So there are certain things where we actually have an observable, objective reality, and not just a subjective opinion, right?
Definitely.
And surely that has to be the basis then of our knowledge. What we can all agree is observable, objective reality.